Okay, so hello everyone, and welcome to this session. In this session, we'll have a joint webinar with Port and Kubecost, and we're going to talk about maximizing cloud cost efficiency, the role of developer portals and cost portals in the world of controlling cloud costs. My name is Moore. I'm a solutions architect at Port. I also have here Aiden, who's our senior solutions engineer, and we have Mike Riggs, who's a senior solutions engineer at Kubecost. Okay, so first off, before I get started, feel free to ask questions during the session. Raise your hand or type in the Q&A. There's no problem at all. We'll try to address everything while the session is ongoing, but we'll also have time for questions at the end. And in addition, this session will be recorded. So if you have a friend or a colleague you want to send the session to, no worries. We'll send you the recording via email, and it will also be on our YouTube channel. So you can send it over. You can watch it again if you need a refresher and so on. Okay, so what are we going to talk about today? First of all, we're going to do a quick intro into portals in general. What are internal developer portals? Where do they help us with extracting information and reducing information overload? And we're going to talk about Kubernetes abstraction and cloud costs in the portal. Then I hand it over to Mike from Kubecost. He's going to talk a bit about cloud cost management. And we're going to have a live demo by Aiden about how to see cost data inside Port and how to understand costs. Perfect. Sorry about that. Okay, so the source of platform engineering comes from all of these major shifts that we're seeing in the modern SDLC. So we see a lot of companies going from on-premise to cloud. We see them changing from monolithic services to microservices. They have multiple dependencies for each service. Sometimes a single service depends on multiple other internal services. Everything is an API at this point, and new tools are coming in every day. And with all of this happening, we also need to keep track of it, but we also need to monitor it and enforce some standards. Now, what this does is this creates a lot of cognitive load and manual work. It becomes very difficult to keep documentation up to date, and DevOps have a plethora of tickets that they always need to address. And we need to go through these manual readiness checklists to make sure that a new microservice or a microservice that's getting a new version deployed in production goes through all of the different checks that we've defined and configured to make sure that nothing gets missed, that we don't cause a downtime or a bad experience for our users. In addition, this also creates a big challenge of tracking costs for all the different resources that we have, all the different cloud deployments, all the different environments. And it makes it very hard to also align with standards and keep track of everything that we have. Now, this modernization, of course, it has a big advantage. It lets us push forward our products and deliver a better experience. But on the dev side, this adds complexity to our R&D teams, and it breaks the developer experience. So in order to help alleviate that issue and solve it, we have developer portals, for example, Port. And Port is meant to be that one-stop shop for all of your information, for all of the developer routines in that one central place. That means it is a place where you can plan your day, plan your features, plan your coming task or your current task. You can use the tool as you're developing, and you can use it also to ship features, and at the end to also monitor them and make any necessary adjustments while they're already running in production. So how exactly does Port do that? Provides you with that end-to-end developer experience. We're talking from the moment that you arrive at the office, you're starting to take a look at what are your open pull requests, what are your open tickets, what are some requests that you've received and need to address. We're talking about everything that you do as you're developing things, going to the different tooling, checking the security vulnerabilities, taking a look at the dependencies and what libraries and APIs are available to you. We're talking about shipping the features, so giving developers the autonomy to actually ship on their own, releasing them from the dependency on the DevOps and the SRE teams. And finally, monitoring all of the systems as they're already running, giving developers the tools to understand, okay, what is exactly going on in my environment? What is happening with my microservice? Is it performing as expected? Do I have any issues that I need to address? And so on. So, of course, in order to do all that in a single place, we need to take in information from a variety of different tools. And the idea of the portal is that it provides with the integrations to all of those tools, to all of those data sources, and it becomes that one source of truth that brings all the data into one place, connects it, and adds that additional context, that additional layer of visibility and abstraction that makes sense both for you and for your developers as they're working in the portal, as they're working on their features and on their products. And you can see here, for example, a variety of different use cases or user stories that are a good idea and something that we see that is very common to expose in the portal and to provide to your developers to reduce the cognitive load, to improve the developer experience, to improve developer efficiency. So in order to create that portal that contains everything and really reduces the cognitive load and improves the experience of developers as they're working on their features, we really like to think of platform engineers as actual product managers. That means that the portal is an actual product with the developers as the actual customers. So we oftentimes try to help the platform engineers that use Port and give them these sort of initial template sentences that they can use to think of use cases and think of sort of ideal scenarios where their developers would use the portal and what would they use it for. So for example, if you take a look at the first sentence, something that is very common that we see is they tell us developers will use a Port to get their assigned tickets instead of checking a tool such as Jira or Linear. Or when we're talking about the second line, when an outage happens, developers will go to Port to see the latest deployments and their health status instead of checking the Kubernetes cluster directly. And of course, you can find an infinite number of options to put in the blank boxes and also an infinite number of sentences. And it's all about talking to your users and understanding, okay, what are the pain points? What are some of the areas where the developer experience is not at its top and it could be improved, and start leveraging the portal to help with those use cases. So how exactly does the portal do that? It does it with a few core pillars. The first one is the software catalog. The software catalog is usually the easiest and most sensible starting point. It's how you configure, basically, you bring over all of the different assets that you have, your services, your repositories, your cloud resources, your tickets, and so on, and bringing them all into one place from all of the different tooling, including, for example, the cost information, which we're going to show and discuss today. And once you have all of that information in one place, it makes it very easy to leverage that additional context, getting information that you might have not been able to see at a glance with each separate tool on its own. Now, when it's in Port in one place, it suddenly becomes a lot easier to leverage that information. Now, the second pillar is scorecards. Once we have all that information in place, we can use scorecards to enforce standards and define how we want our services, how we want our software assets to actually look. So we can look at a given service and say, okay, in order for this service to be production ready, it needs a minimum of 5 replicas. It needs to be deployed in more than one region. It must have a README in its documentation. It must have a Swagger API so that other developers know how to use it, and so on. And it makes it very easy to configure standards that are a good fit for your organization. Because again, as the platform engineer, you are the product manager, you know your organization, you know your customers best, and you know what makes sense for them and what is a good idea for them to focus on, and also what standards you want to enforce. Then we have self-service. A big thing that we want to do is we want to give developers a lot more autonomy in order to improve their experience, in order to reduce those constant tickets that are going back and forth between the developer and the DevOps. Developers have a variety of common tasks that they often need to perform, which are very simple. They need to scaffold a new repository. They need to receive permissions to some cloud resource. They need to create a temporary environment to develop a feature. Now, oftentimes, the DevOps already have pre-made scripts or workflows to take care of those requests. And all they need to do is to get the information that the developer input into the ticket, put it inside their script, and just hit enter to run it. We want to save that unnecessary back and forth and give developers the autonomy to just trigger those actions directly from the portal with simple forms that contain all of the guardrails and basically take care of all of the difficult heavy lifting in the background and just giving the developers a good, powerful experience that makes their day much better, much simpler, and makes them much more efficient. Now, going a step further from self-service, we're talking about workflow automation. With workflow automation, this is a realization that we came from after taking a look at our customers and seeing all the great information that they've brought into the software catalog. And we realized with all of this high quality and up-to-date information in one place, we can leverage that and let machines also take advantage of that information. We're talking CI/CD scripts, we're talking infrastructure as code, we're talking listening to events, for example, an application's health changing suddenly in certain cases or in case of an outage, and so on. And basically creating those automations that make your environment much more reactive to events on its own without you having to go and monitor everything and take care of everything manually. All of a sudden, with all of this information, with all of these automations, you become much more resilient, and it also, again, reduces the load, reduces the need to do everything manually. And of course, none of this would have been possible without a very strong layer of role-based access control, which makes sure that only the correct personas see the necessary information. They do not have access to self-service actions that might be costly or expensive because they provision some sort of resource, and so on, to make sure that the portal is that one-stop shop for all of the users and they only see what matters to them and what makes the most sense for them. So to give a small example, let's talk about abstracting information for developers and specifically abstracting information from Kubernetes inside the portal. So in order to demonstrate that, I'm going to go into Port, and this is our live demo. It's available all the time for free at demo.getport.io. You can just go in and take a look at all of the examples here. This is sort of our open example for how a full-fledged portal can look once you bring all of the information of the Kubernetes and services and GitHub and cost information in with the variety of integrations. This is how a full-fledged portal can look and how it can help you improve the developer experience for developers. And so we want to focus on specifically on Kubernetes. So let's take a look at our catalog and go to the clusters. And I can see here a variety of clusters that I have in my environment. And let's assume that I'm the developer. I want to take a look at one of my microservices, and I don't want to be bogged by all of the unnecessary information that I have in the Kubernetes cluster, because remember, a Kubernetes cluster is a complex component that can have so many different objects. You can have pods and namespaces and replica sets and cron jobs and so on. And developers, most of the time, they don't know all of these things, but they also don't need and don't want to know. Developers, at the end of the day, want to develop their features and take care of their tickets and improve the products that they are working on. They don't want to go into the nitty-gritty details of Kubernetes. So here, for example, we have an abstraction. We can take a look at our production Kubernetes cluster, and we can also see at a glance all of the different services that are running on that cluster. And this saves me a lot of the trouble of understanding every small detail inside Kubernetes because I see the cluster, I see the running services. Let's assume that I'm a developer that's working on the payment service and I see there's some sort of issue. I can get to it right away from here. I don't need to dive too deep, into all the different information. I can also customize this view to make sure that I'm not bogged down with information. And this makes it very easy for me instead of opening the kubectl CLI, or maybe using a different tool such as Lens or some sort of dashboard. And this makes it much easier and much more convenient interface to explore my Kubernetes cluster or explore the service that I have on the Kubernetes cluster. And this will also save time for the DevOps because he will not need to answer all of my questions because I'm overwhelmed with information that I'm getting from Kubernetes. And again, this is just one example about abstracting information. This is all coming from one integration that we have with Kubernetes. Of course, we have a lot more. And this is a great chance to give over the reins to Mike, who's going to talk about Kubecost and how the integration of Kubecost with Port helps you bring all of the cost information and abstract costs in a way that makes sense for developers. So Mike, take it away.
Yeah, thanks, Mark. Appreciate it. We're gonna share my screen here real quick. I've got a couple of slides, and let me make this a little bit bigger. There we go. Okay, I've got just a couple of slides, and we'll take a look at the UI, and we'll talk about some features and capabilities and such. So kind of start off.
I think you can open your video or try to at least, if I may.
Yeah, let's see what it wasn't letting me last time. Oh, there it goes. It's working now. All right, cool. So real quick, Kubecost then, what we've got here is it's a real-time cost management solution for Kubernetes. This is built, the team that originally built Kubecost also created OpenCost, which has been released to the community. It is an incubating CSCF project. We've got a lot of FinOps and engineering teams using Kubecost. We have a very large presence in the community. In fact, I think in terms of single vendors, I think we're responsible for monitoring most Kubernetes or more Kubernetes spend than other organizations. And we are currently managing about $10 billion worth of spend. So it's pretty substantial. And then on the right-hand side there is the the NASCAR side. These are just some of our featured customers. And of course, this does not want to advance. There we go. Kubecost. So for folks that are looking at FinOps type practices, there are three phases effectively. There's inform, optimize, and operate. And so this is kind of the three sort of pillars that Kubecost operates on, especially around Kubernetes. If you've looked, for example, with your cloud service provider bill, they make it not easy to understand exactly what is Kubernetes. They focus very much on infrastructure, but when you try to break it down into the smaller components, you run into some issues. And so Kubecost was built for organizations that are very heavy Kubernetes users. We focus on getting that inform, optimize, and operate specifically for Kubernetes. We run as a workload inside your environment. So for secure organizations that are very security conscious, or for GovCloud, those types of environments, it's very secure. And then again, as I mentioned a minute ago, this is built completely on open source and has been contributed to the CNCF as an incubating project. I don't know why this didn't want to advance. There it goes. So the key use case is this, kind of I touched on it earlier, but the idea is I'm not really concerned about what my EC2 instances are doing and what maybe my database is doing. I really understand what a Kubernetes workload costs. And so towards that, we can use Kubecost to understand how efficiently does an application operate. A lot of times organizations will go out and deploy Kubernetes resources without really understanding what those workloads take to run. And so they're going to go out and typically we see a lot of this, they get over deployed. And then what happens is you end up having these Kubernetes workloads running in that public cloud that are basically consuming resources these resources are being paid for, but they're not being consumed by a Kubernetes workload. So Kubecost was designed to not only address visibility in these environments, but then also to be able to, how can we achieve some savings in these environments as well? So this is kind of the core sort of use case for Kubecost. So let's take a look at, let me see here, did my screen, yeah, just making sure my screen share changed to where I wanted. And we've got this little banner up here at the top. This is a shared environment, kind of like mentioned before, my environment is also a public facing demo. So anybody that's interested can go to demo.kubecost.io and take a look. But I'm gonna kind of show y'all a quick little look at what it is that Kubecost does, what we can see in the UI. So to start with, we can monitor clusters everywhere. And to be kind of just upfront or kind of make sure we're all clear, we're going to see some metrics and things here. Everything that Kubecost does and shows you is based on cost. It's a cost basis type of tool. So we're not looking necessarily at performance type optimizations when we see some of these figures. We're looking at everything with an eye towards understanding and improving costs. So the first thing we've got here is I can monitor all of my clusters across any cloud provider in my environment, my little demo environment. I've got clusters in AWS, Azure, and in GCP. I can see a kind of a high level breakdown for the cost for these clusters. And then we've got some other information on this overview page that just shows some kind of larger scale cloud cost breakdown, some trending information, and then some network cost breakdown down here at the bottom. But where it gets interesting then is allocations. And so again, back to this kind of three phases of a FinOps practice. Step one is, where is my spend going? What am I spending money on? And am I wasting any of it anywhere? And so when we look at this allocation screen, what we're looking at, these are Kubernetes workloads. These are going to be, we're segregated on namespace boundaries. We can aggregate the data sets a bunch of different ways. We're going to leave it at namespaces. For now, this is a very logical way to segregate your workloads in a multi-tenant type of environment, but we can visualize this data in a bunch of different ways. So if I wanted to slice this up by clusters, by controllers, by daemon sets, by products, by teams, we can do that. We're going to focus on namespaces for now. So what I'm looking at is, this is a namespace. In each one of these, I've got some demo apps running in here in these namespaces. And what we're looking at is that namespace is aggregated across all three of those environments. So I'm looking, say, for example, at this Acme Fitness demo app. This cost, $13.03, is to run that application for the last 7 days across all three of those environments. So if I want a bigger look back window, I can just change that look back window here. Again, we talked about if we want to aggregate this, we have different ways we can aggregate it. We can also filter down. So for example, I drill down into a namespace and maybe I want to see particular pods or containers or even labels within that namespace. So I have ways I can then go filter the data. So step one, let's understand where my money's going. So this is, again, looking at Kubernetes namespaces, and we're pulling data across these metrics. So we're looking at these in a more granular cost fashion. We're looking at these across CPU, GPU, memory, storage, network, and load balancer. A couple things I'm going to point out just real quick up here. This is going to lead into more, this is part of Inform, part of Optimize. But this efficiency score, when we look at these workloads, some of these workloads have got very low efficiency scores. This indicates that this workload is typically going to be over provisioned and is going to have some resource wastage. I do have a couple of workloads here that are at or over 100%. That typically means that these resources are under provisioned and could be in some danger of being evicted. But again, for the purposes of this, we are mostly interested in cost. So the first thing we see here is, okay, I've got my cost down to a namespace level. So this is where my application boundaries are. And I've got a couple here that are not particularly efficient. And I'm gonna lean on this guy here. If I click these little buttons out here, I can go down to what we call right sizing. And so what right sizing does, not a bad example, not a perfect one, but not bad. What right sizing does is it lets us take a look at what a deployment is doing in terms of resource consumption. So we can see here that for this particular deployment, this is my Nginx controller. I've got 90 megs requested for memory. I'm consuming 102. So this on the memory side, we're ever so slightly under provisioned here, but where we start looking at then optimizing the workload for savings on the CPU side. And we can see here that this workload has got a fairly low efficiency score. The efficiency score is a blend of memory and CPU. There's some weighting that goes on there as well, but in general, it's an overall look at the efficiency of that workload. And so here, my CPU is not particularly efficient because I'm requesting 100 millicores of CPU. We're averaging about 4, but maxing out at 15. And so what Kubecost says, hey, we can set that request to 22 millicores instead, and then we're going to free up all of these resources. Now we can get to this. There are, when we look at the savings, again, so monitor in this section, we're looking very closely at our Kubernetes cost. We can also look at our assets. This is going to be the infrastructure cost or the infrastructure components responsible for running those workloads. This cloud cost piece here is going to be everything that we can see in that cloud bill. So we do integrate with your cloud billing data. Anything that we can see in that bill, we can give you insight to around here. So the first step, we've got visibility into these costs. And now as we were just looking, kind of step 2 of that FinOps phase is how can I optimize these costs? So this is what we just drilled down into a second ago in that particular namespace. Now we're going to look at it as more of a holistic, bigger picture type of thing. So I like to look at this. Kubecost gives you an idea of how much you can save, what savings is available across. We have 10 different areas that we can look at so we can look at start achieving some workload efficiencies that will result in savings. So we touched on this briefly. A minute ago, we were looking at just a namespace. Now I'm looking at every container workload that's running in the cluster. And we can see here, I've got a number of these that I'd probably want to go take a look at in terms of shoring up these deployments a little bit to make these workloads more optimized so we don't have the resource wastage that we see here. So we understand where our money's going. We've got 10 different ways that we can look at in terms of achieving some of that, achieving some of the savings with kind of an end goal of completely right sizing an entire cluster. So I can select the cluster here that I want to look at, and then I can get some right sizing recommendations for that cluster. So step 2 of that FinOps 3-phase approach, optimize. Now we understand that. The last piece that comes in here is kind of like most products these days. We do have RBOC built in. So I've got 3 roles that are built in. We've got an admin, a read only, and an editor role. So if we kind of put on our admin hats here, an administrator then for that operate part of this is going to want to set some boundaries on these these workloads. Now we've identified where we can optimize the cost for these workloads. Now let's put some boundaries around it and kind of make sure that those developers adhere to these recommendations that are getting made. So an administrator can create a budget. It can be a weekly budget or a monthly budget. It can be based on a namespace, a cluster, or a label. We'll just grab a namespace for now. What I can do is I can create an action then. So when I hit a certain percentage of that budget, I want to notify these teams that they're approaching or that they're at their budget. So we can do that. We can send it notifications via email or via webhooks. And so step 1, I create a budget. Step 2, and these are components that are out in our GitHub repo, and so they don't have a UI. But step 2 is going to be, there is a cluster controller that is out there, and then there's a component called cost predictor, which we're going to look at in more detail here in a minute. But what cost predict does is I can point cost predict at a directory, at a manifest or a directory of manifests, and it will tell me what that workload is going to cost prior to it being deployed. So as an administrator, I can take the output of cost predict, and then there is a cluster controller and a mission controller that's also in our GitHub repo, and then I can configure that admission controller to block workloads from being deployed based on the outcome of cost predict. So I've got a couple options there. I can pull out the big hammer and prevent those workloads from being deployed, or I can just say, hey, let's flag this workload for review later on. So that is kind of what Kubecost does in a nutshell. Again, the idea here is we want to understand where our costs are going at a very granular level. We want to be able to then save some of that money. Savings is always good. Cloud providers don't always make this easy to do. And then we want to put some enforcement against those budgetary recommendations and other things that we've created. Okay, so I am going to stop here. That was just, again, kind of a quick little overview. I am going to make Aiden the host. And there we go. And now, Aiden, over to you.
All right. Thank you both. I appreciate the intro to this and for the demo of Kubecost. I'm going to share my screen. I want to talk through a few scenarios of how you can use Port to take that great information from Kubecost and make it very consumable for developers in ways and in a platform where they're already used to working. So again, like Moore was saying, we're already kind of piling a lot on developers. So it's not just the application code anymore. It's the dependencies, the vulnerabilities, the cost, the resources that all goes into it. So I put together a very simple environment where I've ingested data from Kubecost, actually from the same demo site you were just seeing. And I'll walk you through a few scenarios. So the first one is visibility into costs from a developer, a namespace, a team perspective. So the first thing I'm going to do is go into my catalog here, and I've got a few different views here in dashboards. So looking at the Kubernetes cost per namespace, where you might find this useful is actually from an investment point of view. So we've talked to a few customers who use Kubecost, and they want to figure out, where to invest more in clusters or node pools that might be, like Mike was saying, under provisioned. So the first thing you're seeing here is a couple different namespaces. So obviously I can expand this, see the workloads that are part of this namespace, and then get a look at the overall cost per namespace. So I think where this might come better into play is in the cluster. So we'll have a production cluster, a staging cluster, a development cluster, and you want to make sure that the one that's actually bringing you revenue, your production cluster, is costing the most, and the one that isn't bringing any revenue, development clusters, is not. We're going to talk a little bit in a minute about how you can also control those costs using Kubecost Predict. I'm going to lean on Mike a little bit to talk about what goes into that. But these are a couple different ways, and then finally by team. So again, if you give developers access to Kubecost, Jira, GitHub, it might be a little bit of information overload, and you kind of want to cater it down to as close to what their daily work is as possible. So you've got Kubecost per team. I see that I'm on team A. This is aligned to my services, so I know what I can do to control this. And obviously, like Mike was saying, if you use like AWS Cost Explorer or something like that, that information might not be consumable by anyone other than someone on the FinOps team. So what we want to do is break it down in ways for developers to understand, where am I spending too much? Where could I adjust the configuration of my resources, my clusters, to optimize? And so another way of doing that here is with scorecards in Port. So we could take that great information from Kubecost, and we can create a new scorecard. So giving developers very small bite-sized things that they can do to go and kind of get off what we might call the bad list here is a good way of going about that. So the scorecard that I've put together, obviously, like Mike was saying, the efficiency, you want your RAM efficiency in this example, you want it to be sitting in a production cluster, depending on your policy and the profile, between 80 and 100%. You want to be using most of those resources that you have without kind of risking overusing. So good scorecard view for people to see, I'm on this team, I need to adjust my RAM efficiency. But then initiatives are an even better way to do that. So breaking that down even further and saying, Kubecost has identified that all of our workloads, have this RAM efficiency. What we really want is for right now our production workloads to be brought to a level where they're between 80 and maybe 110%, probably a little bit closer to 80% efficiency. And you can communicate why that's important to developers. So not just handing them maybe a spreadsheet or a dashboard, but saying, you own these things. We need you to make these adjustments, in this case, particularly to RAM efficiency, to bring some of these resource configurations down, so we save a little bit of money and you don't sacrifice any of your application, the way that it works. So this is a view. that would be important for developers, what I would recommend is probably putting something like this in the reference in that homepage that I started on, and then let people go see this by team. So again, we're only taking production clusters and optimizing that RAM efficiency. And if I'm on team A, I can go see that. Hey, I've got a couple workloads here that need to be adjusted. I just need to bump down that RAM a little bit to free it up for other people who can use it and make sure that I'm efficient and that my application still works. And then, obviously pie chart view looks like half of our production clusters and workloads are at that proper level of RAM provisioning that we've set with that profile. Going a little bit further, obviously, the IDP and in this case is not focused solely on costs. So your general services, knowing which clusters they're deployed to, what running instances you have of them, and then connecting them also to their cloud resources. So it's not all Kubernetes. What you also have is cloud costs directly from Kubecost. So how much are my applications costing me? And then how much are the services costing me? So again, kind of having a good strike of my services that bring the most revenue presumably will cost the most, and we don't want the ones that don't bring as much revenue costing a whole lot. And like Mike was saying, obviously this is for organizations like he showed on his NASCAR slide, and organizations like we have, highly regulated. Not everybody can see everything. So having good RBAC to control who can see things and who can do things within an IDP is very important. So what I've done, actually, Willie mentioned it, I put this together, a my Kubecost view. So I've set an initial filter here that grabs the logged in user and says, hey, if there's any costs that are aligned to the team of the user who's logged in, present them here, and they still get the full functionality of this table view where they're able to see, here are my costs. And obviously what I would recommend from there is turning on that scorecard and initiative to make sure that they're doing something with this information and not just kind of just being able to view it. Last thing I want to talk about here is self-service. So Kubecost has this great tool that allows you to predict what service might cost. A new Kubernetes resource might cost. In self-service, what you're able to do is abstract away not only the creation of a developer environment, but the estimation of the cost. So you're not telling developers, hey, if you want to go test this feature you've been working on, this service altogether, go through this kubectl, type these things in. Here's a document on how you can do that. You can abstract all that away. So with a self-service action like create dev environment, we allow developers to select a service, as I'll show here, and set a time to live. And that's important, again, from that cost perspective, that I think a lot of the things that draw down on these cloud bills are setting a time to live that's too far out, or not setting a time to live and letting these sandbox resources consume a lot of your spend. So you have your options. Everything you're seeing here is completely configurable. You can ensure that only services that have been have gone through code review will go and eat up those development resources. And what that might look like is in the back end, and I'll blow this up a little bit, and maybe back down because it's disappearing. In the back end, once you create this, you could do a couple things. So manual approval, if your predicted cost is going to exceed your own budget, you need to go get approval from your team leader to be able to do this. Or a little self-remediation is just adjusting that time to live. So I've gone through this workflow. I have a backend that's engaging that Kubecost cost predictor, and it's saying you're asking for a development environment that will last this long, that will consume these resources. It's costing you about this much. Consider adjusting this if it's outside your allocated budget. But again, like I said, with and I'll show you the back end of this. With the dynamic permissions we have available, if you do have a development environment that's going to exceed your own budget, you can work in there where you have to get manual approval. So there's a lot you can do with the self-service action that, kind of generally scaffolding a new service, requesting access to a resource, enriching a service, and creating a developer environment that you can do with an eye to cost efficiency and keeping developers on the golden path. That's about all I was going to cover. Mike, do you want to talk any more about how the Kubecost predict works?
Yeah, I kind of beat it up real quick. So basically what it is we have an API. So everything that can be done in the UI can also be done via the API. So we have an API called Cost Prediction API, and basically what it does is it accepts things like cluster IDs, namespaces, a time frame, and you basically point it at the directory manifest that you want to deploy. And this does rely on Kubecost being installed on the target cluster so that we do have an understanding of what the costs already are already there for that cluster. And then what happens is you send this API call and you get back a response that will show not only if you're expanding a deployment, if that deployment's already running, then it will show you what the cost delta will be. And if it's a brand new workload, it'll just show you what that workload costs prior to being deployed. There are a couple of caveats here. It works with I'm gonna draw a blank here. It works with deployment, stateful sets, and pods. So it's still kind of a newish sort of tool. And then the use case that Aidan was talking about in terms of maybe consider if this goes over your budget, consider changing your time to live. We have a couple of different ways. There's a cluster controller that we have out in our GitHub repo that can be used for that. But we have customers that are using tooling like Gatekeeper or Caverno for that admission controller part, and it's just a matter of kind of piping that output into Caverno and then setting your enforcement using that tool. So it works pretty well. It's again pretty new tool to Kubecost. I expect it will improve as it goes along, but that's kind of where it is now.
Awesome, thanks, Mike. So I don't know if there are any more questions from the attendees or.
Yeah, I'm gonna ask one question on behalf of one of the attendees, and then if anyone else has any additional questions, we'll be happy to answer them. If not, we'll close the webinar. There's this question about across different customers. Mike, going to you. What kind of cost data do you see exposed to developers, and what is the impact of exposing that cost data to developers, both in terms of the behavior and kind of business results for the customers themselves?
Yeah, so I'm gonna pull out this screen share again real quick, just so we can take a quick peek at this. I'm gonna make my window a little bit bigger. And so the idea here is as a developer, if we look at my allocations page here, again, these are going to be, this is where I think most of our development teams are going to spend their time. So what I could do is using RBAC, that developer can log in as part of a team or a product owner or whatever it may be. They can see the resources that their workloads are consuming. But I think the key things that developers are looking for now are going to be along the lines of this efficiency score that we've already discussed. So this gives them a way they can come in here, get an efficiency score for their workloads that are running in their namespaces, and then come over to this savings tab. And again, I'm clicking around in the UI for the just so we can follow along. But again, this can all be done totally programmatically using an API. But the idea is, as a developer, I would be able to monitor my own costs. I could create reports around these costs that get developed, that get sent out to my team daily, weekly, monthly intervals, so that my team is aware of these costs. I can monitor them here, and then I can come over to these saving sections. And depending on what I wanted to achieve, and again, typically your development teams are going to be more interested in container requests, whereas a lot of times your infrastructure teams are going to be more interested in things like persistent volumes and underutilized nodes, unclaimed volumes, things like that. But as a developer, I would go look at making sure that my container requests were optimized in terms of resource utilization and cost. And then obviously, then the effect on the on the business there then is we can either we can get more work done at with less cost. We can improve the bin packing of our clusters. We can just basically optimize those workloads in terms of cost.
Thanks. any additional questions, plop them into the Q&A, or if anybody, any one of the panelists or hosts wants to ask something, and if not, we'll say thank you to everyone. And we'll also be sending a recording of this webinar to everyone that registered. So I think we're done. So thank you, everyone. And it was a pleasure having you.
Thanks, everyone.
Thank you.
Thank you.